Hi, everybody. Welcome to Factorial Analysis of Variance. So in this chapter, we're going to talk about a factorial ANOVA. Last chapter was one-way ANOVA. Now we're going to talk about a factorial ANOVA. The difference between factorial ANOVA and one-way ANOVA is that a factorial ANOVA takes care of more than one independent variable. We call those factors. A one-way ANOVA has one factor. A factorial ANOVA has more than one factors, at least two. When we're looking at this, so for example, let's take a look at these data that I have in front of us. So let's say that I thought that your major affects your GPA, but I also think that that kind of depends on what school you go to. So I think both major and school interact to affect GPA. So that means that major is an independent variable, school is an independent variable, and GPA is the dependent variable. A factor is an independent variable. So for example, major would be one of the factors. School would be a separate factor. Now when you look at this, you need to make sure you understand how many factors you have and how many levels are in the factors, because the way we're doing analysis of variance, we're only using categorical factors and a continuous dependent variable. So that means that when you're looking at your factors, your independent variables, right, you need to know how many levels we're talking about. So major is one variable, and it has different levels. For example, psychology is a level, business is a level, drama is a level, and then psychology, business, drama, right? So these are three levels. Psychology, business, and drama are levels of the variable major. In this case, that variable is called a factor because it's going to help predict GPA. All right? So major is a factor, and it has 1, 2, 3 levels. School is a separate factor, a separate variable, and it has 1, 2 levels. CU Boulder is one level, CSU is another level. We would call this a 3x2 analysis of variance. 3 because the first factor has 3 levels. By 2 because the second factor has 2 levels. The first factor is major, and it has psychology, business, and drama. That's 3 levels. The second factor is school, and it has 2 levels, CU Boulder and CSU. That means it's a 3x2. But what about GPA? GPA is the dependent variable, not a factor, so it doesn't get one of these numbers. This is a 3x2 design. Compare that to this one. This is a 2x2. We still have major in school, but now when you look at major, whoops, go back. When you look at major, how many levels do we have? 1, 2 levels, and 1, 2 levels. 2 levels of major, 2 levels of school. 2x2. The dependent variable is GPA. The reason why you do a factorial analysis of variance is because you don't want to just do two separate t-tests. You want to see how these mix together. Let's say that I think that being a psychology major means that you're going to have a better GPA. But I only think that's the case if you're at CU Boulder. I think if CSU, it doesn't matter if you're a psychology major or a business major. I think it only happens when you're at the school. The reason when you're at CU Boulder is your school. So the reason why this is important is because we can say, you know what? I think that the major you have affects your GPA, but I think it depends on this other factor. In this case, that would be the school. If we want to look at the mix of that, then we're not just looking at, the mean of all psychology majors compared to the mean of the business majors, or the mean of all CU Boulder students compared to the mean of all CSU students. We want to mix them up. We want them to interact. And that's why we need to do what's called a factorial analysis of variance. And to get a little bit more into this, let's talk about the difference between what's called a main effect and an interaction. So to do this, let's look at some new data. I want you to look at these data right here and tell me what kind of design this is. Okay, so let's look at this. Let's say that I have a hypothesis that you will eat more bowls of cereal if you live off campus than on campus. but I think it depends on whether or not you have a car. See, here's my theory. I think that people who have a car um, and live off campus, they can they can eat more complicated foods, or maybe even go out for breakfast or something like that. Whereas people who do not have a car and live off campus, it takes a long time for them to walk, and so they've got to they've got to eat cereal, they've got to eat something fast and go. I think people who live on campus, whether you have a car or not, doesn't matter, because you can take your time and eat, and then you just kind of walk over to your class, and it's not a big deal, right? So I think that living on or off campus affects how many bowls of cereal you have, but I think it depends on whether or not you own a car. In this case, I think that residence and car affect bowls of cereal. The dependent variable is bowls of cereal. Residence and car are factors. There are two levels of residence, on campus and off campus. There are two levels of car, yes and no, meaning yes, I own a car, no, I don't own a car. This is a 2x2 design. Two levels of residence, two levels of car. They're both factors that affect cereal, which is the dependent variable. It doesn't get a number. All right. We need to talk about something called main effects first, because when I put this into an analysis of variance, I'm going to get several different things. And the first thing I'm going to do is it's going to say, all right, well, let's assume that you wanted to know, as if it was a t-test, the difference between on campus and off campus, right? Or let's assume, like an independent samples t-test, you want to know yes car or no car, which one you would do, right? That would be the main effect. The main effect looks at one of the factors on the dependent variable alone, without the influence of the other factors. So for example, when you look at this, the main effect is going to be the effect of each factor by itself. The interaction is going to be the combination, the mixture of them. So let's look at the data that we were just looking at in terms of a main effect. The main effect that we would be looking at would be comparing these orange scores to the blue scores, right? Everybody who lives on campus compared to everybody who lives off campus. So these bowls of cereal compared to these bowls of cereal. And if you look here on the right, I have the average. So 2 plus 3 plus 3 plus 2 divided by 4, that's 2.5. 2 plus 4 plus 3 plus 6 divided by 4 is 3.75. All right? So what we're really doing is comparing this group of scores and their mean, 2.5, compared to this group of scores and their mean, 3.75. The main effect looks at on campus compared to off campus, as if car just didn't even exist. That's why it's kind of grayed out. It doesn't matter. A main effect just looks at one of the factors by itself, right? It's comparing on campus to off campus, one of the factors by itself. That means that we're going to have a separate main effect for car, right? The main effect for residence is comparing on campus to off campus, 2.5 to 375 over here, but we'll have a separate main effect for car. It's comparing all these oranges. These are the yes car, yes car, yes car, yes car. Those are the oranges. Yep, yes cars compared to the no cars. All right. When we do that, we have the separate main effect for whether or not you own a car. That is 2.5 and 3.75 right there. Does that make sense? Okay, so whenever you're doing this, you will have as many main effects as you have factors. You have the same number of main effects as you have factors. And an analysis of variance is going to give you a statistic for each of those main effects. It is going to look at on campus compared to off campus, that's one main effect. And then it's separately going to look at yes car compared to no car, that's a separate main effect. All right? Main effects are each factor on the dependent variable by themselves. By themselves. Looking at the levels of each factor on the dependent variable without the influence of the other factor. Okay. An interaction is the combination. So you see these different colors? So this reddish color is on campus with a car. The yellow is on campus, no car. The purple is off campus, yes car. And the dark blue is off campus, no car. The interaction is how these factors interact with each other, how residence interacts with car on how many bowls of cereal you eat, right? It's saying, all right, I want to look at the combination of living on campus with owning a car compared to the combination of living on campus with no car compared to the combination of off campus, yes car, off campus, no car. That means we're going to have 4 different groups involved in that interaction. Here's one way you know how many groups you should be looking at. Remember, this is a 2 by 2, right? 2 levels of residence, 2 levels of car. 2 times 2 is 4. That's how many groups you're going to have in the interaction. So if you notice down here, each of these different groups has their own mean. So people who live on campus and own a car, yes, own a car, they have bowls of cereal 2.5. The on-campus no car also averages 2.5. The off-campus with a car averages 2.5, and off-campus with no car averages 5. This is the interaction that we will be looking for in the analysis of variance. So another way to look at these same data is by looking at it like this. Okay, so you see here, we have the rows. Those represent your residents. The rows represent residents. So this is all the people who live on campus, all right? And then the columns represent whether or not you own a car, yes or no. And these are the combinations. So people who live on campus and yes own a car, they average 2.5. Off campus and yes own a car, they average 2.5. Off campus, no car, they average 5. On campus with no car averages 2.5. These means that you see on the edge, those are what we call the marginal means. They are the comparison for the main effect. Remember, the main effect is looking just at on campus compared to off campus. Okay? As if car didn't even exist. That's why we have these over here on the side, because there's no combination with whether or not you own a car. It's just on campus compared to off campus. And the same thing over here. Here's the other marginal means. The other marginal means are whether you own a car yes or own a car no, right? We don't care about whether you're on or off campus right there. The main effects are just the factors by themselves. We put these means in the margins. That's why we call them marginal means. However, in here, these that are in the table, these are the interaction terms. And the difference between them is what we call a simple effect. So for example, this off campus with no car, the average is 5. On campus with no car is 2.5. Comparing the combination of those two, comparing 5 to 2.5 right there, that would be a simple effect. A factorial analysis of variance will give us each of the main effects and the interaction. And what we normally care about is the interaction. The interaction kind of trumps the main effects. It gives us more information, right? By the way, you can see right here, the average of 2.5 plus 2.5 is 2.5, the marginal mean. 5 plus 2.5 divided by 2 is 3.75. That's why the marginal means are there, right? You'll see where those are. You can tell what the marginal means are just by these simple effect, each individual group mean right here. Okay, so to do this, let's go ahead and show you how to do this using RStudio, how to calculate it. From here on out, we're not even going to mess with Excel on this. We're going to only do this on RStudio to show you what it looks like. So let's go ahead and go to RStudio then. And I have already imported these data. So now I'm going to attach my set. So this is the set, factorial ANOVA example for video. That's the one that I want. So factorial ANOVA example for video. Now I've attached it. Now I can use it. So just to make sure that you know, these are the same people, right? So now I've got these participants, whether they live on campus or off campus, whether they have a car, yes or no, and the bowls of cereal, right? So remember, the dependent variable here is going to be the number of bowls of cereal, all right? Let's make this just a little bit bigger so people can see it. The way you do this is first you start with creating a model. It can be whatever you want it to be. You can name it whatever you want. I'm going to name my model. What am I going to name it? I'm going to name it after the town I was born in. I wasn't born in it, but a town I grew up in Nebraska, which is Kearney. So I want my model named Kearney, and Kearney is going to be an analysis of variance. This is the same way we did the factorial. We start with the dependent variable, which is going to be, in this particular case, let me pull this down so you can see it, just to make sure that we're clear. going to be bowls of cereal, right? That's the dependent variable we want. Bowls of cereal. And we want it separated by the residence, right? Whether you live on or off campus. But that is just going to give us the main effect. We don't want just one main effect of residence. We want to add another main effect. So I'm going to actually put the plus button right there, the plus in there, and say I want the other main effect too, the main effect of car. But we don't want just one main effect plus one main effect. We also want the interaction. The interaction is going to be residence. Let's get this right. Residence colon, and there's different ways you can do this actually. Residence by is the way you say this. Residence by car. Meaning the interaction between residence and car. So when you do this analysis of variance, you need to tell it that you want each of the main effects and each of the interactions. You're saying each of the interactions. What are you talking about? Well, if you had more than two factors, then you would also have more than two possible interactions. In this class, we're going to keep it to one interaction, right, at a time. Okay, so I need to put the main effect of residence. That's right here. Then I put in the main effect of car, right there. Then I need to do the interaction residence by car. It's right there. When I push enter, nothing happens because all this did is created something called Carney, right? So now I'm going to get the summary of Carney. And here it is. Let's make this bigger so you can see it. Let's make it so you can see. Okay. What you see are three separate lines with three separate F values. So for example, this right here, this line is the analysis of variance for the main effect of residence. It's saying, what is the difference between people who live on campus and people who live off campus? That's what it's saying, right? It's saying, is there a significant difference between those? Remember, we looked at those means before. It was 2.5 compared to 3.75, okay? And what this is saying is that there's no significant difference. The probability is 0.132. That's greater than 0.05. So there's no significant difference overall between people who live on campus and off campus as to how many bowls of cereal they eat. What about owning a car? Now this is the main effect for car. It is just looking at whether you own a car or not. Yes car compared to no car. And again, there's no significant difference between how much cereal people eat depending on their car. This right here is the interaction term. It is looking at all four of those means. Remember, on campus, yes car, on campus, no car, off campus, yes car, off campus, no car, those four means to see if there is a difference. And in this case, there is no significant difference. Once again, if you didn't happen to know what the means are, then you would have to go in there and tell it to tell you what the means are. And the way you would do this is by looking at the apply. This is the same way we did it for the one-way ANOVA. We'll start with the interaction terms. So bowls of cereal, and I want it separated by residence, and I want the mean. These are the means, 3.75 compared to 2.5 for living off campus compared to on campus. Okay? These are the means we're looking for. These are the marginal means. We do the same thing for our main effect for car. T apply, bowls of cereal, and instead of residence, car. And then I want the mean. People who own a car, the average is 2.5. People who don't own a car, the average is 3.75. Okay, these are our marginal means for the main effect of car. But now we need to talk about the interaction term. Again, we do T apply, but we've got to do something a little bit more specific. Bowls of cereal, because the dependent variable always comes first. Bowls of cereal is first. But now what we're going to do is we're going to say the word, we're going to say interaction. And we're going to add the two variables that are in our interaction. They are residence, comma, car. And then we tell it, I want the mean. So the dependent variable first, and then you say interaction, and in parentheses, the two different variables that you want, residence and car, and then you need to tell it the mean like you always do. When you do that, here's what you get. Notice that this is the interaction. People who live off campus with no car, they have an average of 5. On campus with a car, average 2.5. On campus, no car, average 2.5. Off campus, yes car, average 2.5. This line right here is telling us that there's no significant difference between any of these 4 groups. Okay, now I want you to try it with a new set of data. So I'm going to detach this and give you the new set of data. I'm going to detach factorial, and we'll use a different set of data. Now I had used this for an extra credit thing in a previous semester, so that's why it's called what it's called, extra credit review data. Okay. When I attach these, I get different data. Let me show you what these data look like over here. Nope, that's not the one. There they are. Okay, so let me tell you about these data that I totally made up. Okay, here is a factor. Well, it could be a factor, right? It is a categorical variable called relationship. Let's count how many variables how many levels it has. It has in a relationship, it's complicated, and single. Those are 3 levels of the variable relationship. Here's another variable. During your last breakup, were you the dumper or the dumpee? Right? So last breakup is the variable. The levels are dumper and dumpee. Attachment is a separate variable. You can be either insecure or secure. Then over here I have loneliness at the time of breakup. Higher loneliness means higher scores means higher loneliness. Loneliness now, which is higher score, higher loneliness, and satisfaction level, higher scores mean higher satisfaction. These are continuous variables. So let's say that my hypothesis is that people who are, let's see, I think that people who are in a relationship now, compared to single or it's complicated, people who are in a relationship now and who were the dumper at their last breakup have significantly less loneliness now. So follow me on this. I think that whether or not you're in a relationship affects your loneliness now, but it depends on whether you've been dumped in your last breakup, right? Specifically, I think dumpers who are in a relationship have significantly lower loneliness than basically everybody else. So the first factor is relationship. The second factor is last breakup. The dependent variable is loneliness now. What kind of design do I have? This would be a 3 by 2 because there are 3 levels of relationship. In a relationship, it's complicated or single compared to, and the other factor is last breakup, you were the dumper or the dumpee, 3 by 2. The dependent variable is loneliness now. So let's go ahead and do this right now. So I'm going to name this, let's name this the town I was born in. I was born in Provo. Provo is going to be an analysis of variance. The analysis of variance, we start with the dependent variable, which is loneliness now. Then we use that little squiggle, right? Because we want to separate it by relationship. But not just relationship, because if we left it like this, we would only get the main effect for relationship. We want relationship plus, oops, there we go, plus last breakup. But this is only the main effect for last breakup. We don't want just two main effects. We also want the interaction, which is going to be relationship by last breakup. Okay, when we do this, it does nothing except it creates something called Provo. So then we go in there and say summary Provo. When we do this, we get what we want. And let's see what we want here. Look at the whole thing. Okay, because we have long variable names, it's a little hard to see. Whoop. Come back up. All right. Let's take a look at each of these. This is going a little bit over because it is just a long thing. So let me just show you again. No, it's too long. Relationship and last breakup is long, and so it's going on to a new line. So this is relationship's main effect. That's the F value, and here is relationship's P value for the main effect. That's saying that there is a significant difference somewhere in the relationship status. Here is the main effect for last breakup. And here is the p-value for last breakup. It is over 0.05, so there's no significant difference between dumpers and dumpees. The interaction is the combination of your relationship status now and what happened when in your last relationship when you were dumper or dumpee, and there's no significant difference between that combination. So what this is saying is we have one significant main effect. We have a significant main effect for relationship status. That is, we know that somewhere in there, there's a difference between people who are in a relationship and who are not in a relationship. Now, when you look at this, you might want to look at what are the means. The T apply works in the same way. So we want to know loneliness now, right? Separated by relationship. And we want the mean. So this is saying that the loneliness for people in a relationship is 7.50. It's complicated, it's 5.25, single, 5.75. We don't know which one of those is significantly different from each other. We don't know. We would have to run a post hoc test or a pairwise t-test, like we would for a analysis of variance, a one-way analysis of variance. So for example, if we want to do a pairwise t-test, because we'd planned on this before, we would do a pairwise t-test with loneliness now as the dependent variable, comma, independent variables relationship. And we need to adjust the P, so P.adjust. P-adjust method equals, in parentheses, Bonferroni. And here's what we see. People who are in a relationship have a significant difference from people who are it's complicated. People who are single have a significant difference from people in a relationship. It's complicated, it's not different than single. When we look at those means, we see that that means people who are in a relationship are significantly more lonely, because more higher scores means higher loneliness, than is complicated or single, and is complicated and single are not significantly different from each other. We want to look at the other means. We go T apply. And again, loneliness now is the dependent variable. The other independent variable is last breakup. And again, we want it to tell us our mean. Now in this case, we know that these are not significantly different from each other. How do we know that? Well, look right up here. This analysis of variance told us that last breakup, here's the main effect, that is the F value right there. So here's the F value for main effect, 2.40. And this is the P value for last breakup, the main effect of last breakup. It is greater than 0.05. We know that there's no significant difference between dumpees and dumpers in their loneliness now. If we want to look at the means for the interaction, we do the dependent variable, comma, interaction, and relationship. We put everything that's in the interaction, relationship, comma, last breakup, and then comma, mean, because you always have to tell it you want the mean. So it should look like this: loneliness now, interaction, relationship, comma, last breakup, in parentheses, the mean. And this is saying that here are our different groups. Now remember, there's three different levels of relationship status. And then there's 2 levels of last breakup. That's a 3 by 2. 3 times 2 is 6. So that's why we have 6 different groups right here. And what it's saying over here, so let's take a look at our analysis of variance. This relationship by last breakup right here, and this p-value of it, they're not significant, saying that there is no significant difference between any of these 6 groups. No significant difference. A comparison, a main effect would be comparing this to that, right? In a relationship dumpy to single dumpy, that would be a simple effect. None of these simple effects are significant. Okay, we'll go ahead and stop there, and we'll talk about what to do when there are significant effects in the interaction in the next video.